So this idea came from the famous GreatScott's channel, an adjustable bench power supply. The amount of times I've needed to power something and had to rely on these, as soon as I seen this idea, I needed to build it. A cheap 10 amp, 100 volt ammeter/voltmeter, some panel mount fuse holders, a selection of fuses, a load of binding posts, a car panel mounted cigarette lighter with USB adapter, a 24 pin to 24 pin ATX power supply connector, some control knobs, a bronze rated power supply unit I had laying around, some PCB headers, LTC 3780 boards, some 10-turn pots. In the end, I had to use a singular. Now, whilst desoldering the surface mounted pots, I messed up one of the boards. As mentioned on Instructables, this has been a noted problem. Another guy suggested to cut or bend them out, which is what I ended up doing. But in the order of working out which pot I needed, I ordered the wrong pot. The K value, the zeros, it just all got a bit too much and the wrong one come. Which in turn, I had to buy another board as it had the dreaded red bolt. But it turned out, after testing with a multimeter, one of the pots were damaged anyway. 2 lessons here. Lesson 1, double check and buy once. The second lesson is to test items before using them. In the end, I bought another buck boost converter board, 1 to 30 watts with a maximum current rating of 8 amps. This only costed me £6.59 compared to the £10 mark, which is possibly not as efficient as the other board, and I believe that it will not handle as much amperage as the other board. But another problem was the pots on the new board only would come in 1 turn rather than the 10-turn pots that we could have got to replace by using the other buck boost converter. But as the degree of accuracy I will need, this doesn't really bother me. So I decided to be a Scrooge and went for the cheaper board. Without any further ado, let's get building. So here I am taking the donor case apart. I apologise for the low lighting, resulting in grainy footage, but it does get better. Next is prepping the case, taking out any old rivets and PCB mounts. Removing the labels and the sticky glue has to be one of the most tedious, annoyingest jobs I can think of. With this video, I just wanted to show you how long prepping a case can actually take. Rather than buying something new and turning it into something that you desire, recycling, on the other hand, is a bit more time consuming. It would have been a lot easier just to have brought a new plastic case. So with the holes pre-made in the case, I thought I would weld them up and then grind them down. I have a flux core 2-level of power welder, and with 2 levels it comes with 2 speeds automatically selected and chosen for you. Not the best. My welding skills are completely rubbish, let alone with this flux core welder. It was a little bit too powerful, and if I tried to slow it down, the wire feed speed was a little bit too slow, and it kept burning holes right through it. So in the end I gave up on that idea and turned my attention to mounting the PSU. After that I had a brainwave, an idea. I had some black acrylic laying around to hide my welding capabilities. On the right I tried to mould it to the shape of the case. This is okay, it could have done with a foam back padding just to help keep the pressure even all around. Later on, this is going to be screwed down, so it doesn't really matter. Using a step drill. I've only just got into using them, noticed about them. These things are awesome. I drilled a few holes for the front ventilation. As you can see, my workspace and tools are quite limiting. As cutting out the hole for the cigarette lighter socket, the acrylic cracked on me. which wasn't as bad as I thought when I heard it, and I kind of guessed that this was going to happen at some point or another, even though I was going as slow as possible. But in the end, I kind of made it like this should have happened for a reason. And to be honest, I don't think you can really notice it in the final product. A little play around of where I wanted the terminals and the fuse holders to go, and the voltage and amperage meter, I marked off and drilled the holes. I've always learned to do a test fit as you're working. Nothing worse than putting it all together just to find out something is misaligned, or there's a little bit out here and a little bit out there. So I tend to put things together as I go, and then when it comes to it, I'll strip it all down, paint it, spray it, do whatever I want to do with it, finish it, and I know when it comes back together, it's gonna go back how I want it. I got some safety glasses and just wanted to see how well they vented without any condensation. They were actually quite good. Now to cut the holes in the metal case, I would strongly recommend, if buying a pillar drill, to buy a decent one. The chuck and alignment on this has had a case of the wobbles, causing any fine work to allow the bit to skate around. Now, just to finish up the rough edges and making the hole for the ammeter, stroke voltmeter, a quick sand and ready for the paint. I said the case and the recycling of any components will take the longest. Now time for a quick degrease. I always like to heat any metal objects before spraying them. I also think it helps for the paint to adhere better, and also after each spray that I do, I will then also place it in the oven. Now we're not trying to roast it here, we're just putting it in, I really can't remember, maybe a gas mark 1, 2 at the very most, and it will stink the whole house down. For the black inside I used a regular spray car paint. For the outside, I use some barbecue paint. I've noticed before in other processes and projects I have done, it will take a little bit more abuse before cracking and chipping. It is a little bit more expensive. But for both, I have used an etcher primer. I decided to keep the original blue of the outer of the case. It was a little tatty around the edges and gave it a little bit of character. So I ended up engraving into the plastic front panel for the voltage, rails and the maximum amperage that it can take. I then dripped paint into the gaps, ready to be sanded off. If I had to do this again, I would probably use stickers. Now for the reassembling. As all was pre-fitted, this was quite a smooth job. These 1-turn pots are a lot cheaper than the 10 turns, and they have an annoying little lug on the top that you have to file down to get them to lay flush on the case. On the back of the meter, there is 2 very small screws, and these are there to adjust the current and the amperage to calibrate, and they are really sensitive. Each of these terminals has its own fuse. As you can see, the adjustment is very sensitive. It can take a little while before the power drops, but I'm not too sure if this is the resolution of the amp voltmeter or whether it is the buck boost converter taking a little while to cut down that power. Here I'm trying to see how well the meter is calibrated compared to the multimeter I've been using. Now to pop with it all back together again. This took longer as what it should have done, as my rivet shafts were the wrong size for the nozzles. Now we're sanding down the protruding paints, and this was a labour of love. I was going to buff out the scratches from the regular grit sandpaper, but then decided to give it a more of a brushed look finish. I really needed to get this project finished as I was running out of space on my hard drives for the video content, and I needed to make other videos of my daughter, etc. playing, and I needed to get on with other projects. What this shows here is that when the amperage is set really low, for some reason the boost buck converter hangs at around 3.5 volts. But as soon as there's any draw in power, then it drops back down to the 1.35 volts. I finally made it. It took a lot longer than I thought. Ordering, waiting for the parts, reordering, waiting for the parts. The case was almost a disaster in itself. It took far too long prepping the case, but I wanted a sturdy case that would hold up to being shoved in the corner of my room and general wear and tear. Here I am testing out the constant current, and in accordance to Ohm's law, the voltage and the amperage are in relation. Later I have played around with a few more electrical devices and found this is perfect for my needs. I believe that having the amperage turned down really low is somehow switching the buck boost converter into producing maybe more voltage. I'm not quite sure. But this has been a good project. I've totally enjoyed it. It's been a good learning curve. Lessons have been learned. Test the gear that you get that comes through your door. Anything that you've brought recently and you just lobbed it into that circuit thinking it's going to work. Hey, presto, what could possibly go wrong? It could blow or fry a number of components and then you'd have to restart again. I think next time, if I was to do it, I've looked on eBay. eBay are selling probably cheap Chinese bench power supplies for around 50 quid. I think, do I really need the other 3.4 or 3.5 and the 5 volt and the other 12 volt? Yeah, I do. I might not need it right now, but sometimes it's nice just to have that. And those 3 other rails, they have a lot, and I mean a lot of amperage that can be used up on those. So if I've got something, say a Peltier device, that is drawing quite a hefty amperage, I'll go straight to my 12 volt. I wouldn't even consider using the adjustable power supply. All of the fuses are rated slightly lower than what each of the rails on the power supply unit can take. Okay, over and out, bye.